What is up, Flutter devs? Today, it's time to start the API design for the Flutter processing port. And that begs the question in a new project like this, when we're literally facing an empty canvas, where do we start? Well, like all successful people, we will start at the beginning. And what exactly is that? What do we do? Sometimes in an app development project, you start with a bunch of wireframes and specifications. Other times you start with server endpoints. Other times you start with database schemas. You start with what you're given. You start at the beginning. So let's jump over to the desktop and see what makes sense for us. What we're given when it comes to processing is we are given this existing processing system. I mean, processing is something that already exists. People use it in a particular way. And so right off the bat, if we look at a processing sketch, what every user of processing needs right out of the gate is two methods, one called setup and one called draw. That is the beginning for someone who uses processing. And therefore, whatever we create, if we're trying to provide processing style capabilities to Flutter developers, these two methods, these two hooks, these opportunities to draw stuff, this should be our beginning as well. We need to figure out how to make these functions or hooks or opportunities available to our users, the Flutter developers that will use this package. In other words, the way that we're approaching the start of this project, we're not using a designer's wireframes. We're not using a back-end engineer's endpoints or database schema. We're putting ourselves in the mindset of the person who's trying to use the thing that we are going to build. It's like we're teleporting into the future and we're saying, okay, when this thing is done and ready to be used, how do you use it? And then we work backwards. We know we need a setup hook and a draw hook. The question is, where, when, and how do we expose that to the users of this package? Let's go over to the package and figure that out. So here we have the project opened up here in the IDE, picking up from where we left off in the previous video. At the moment, all we have is this empty file here. There's no source code. Where do we begin? The first thing we're going to do is a little bit of structural work. In a Dart or Flutter package, let me show you what you typically do to structure it. Typically, a package has a single top-level Dart file, which is named exactly the same way as the package, in this case, Flutter_processing. Then there's a source directory, and within the source directory, you have a bunch of package private files. Let me show you what I mean by that. I'm going to create a new Dart file. I'm going to call it _core.dart. Why core? There's nothing special about this name, but let's think about what we're building here. We're about to design the APIs that are used everywhere in a Flutter processing project. These are, in other words, core APIs. They are APIs that everything will reference. And I think a file called core is a reasonable place to define those. Otherwise, there's nothing special about the name. However, the underscore right here is important because that says nothing outside of this package can reference this file. But then that begs another question. If we're going to define important stuff in this file, but nothing can access this file from outside the package, how do developers actually use what we're writing? And that's when we come back to this top level file and we will say export source/core.dart. What this export line does is any project that imports this one file called Flutter_processing will automatically get everything inside the core file. What this does effectively for us is it means that we can structure our code in whatever way we think is appropriate, and that structure won't affect any of the end users. We might have 100 different files in this source directory. We might have subdirectories in this directory, but the only thing that our users ever import is this one file right here called Flutter Processing. That's the idea behind the structure here. That's where we're getting started. Here in core, this is where we now will actually begin our work. Once again, what are we doing? We want some kind of setup method and draw method, and the user should be able to fill the background, draw rectangles, circles, lines in those methods. How do we achieve that? First, let's remember that we're operating in Flutter, which means we're operating within a widget tree, which means if our users want to display something visual, they need a widget. So let's say that we begin with a stateless widget called processing. Now, I don't know if it should be stateless or not, but until we have a reason to make it stateful, I'm going to make it stateless. In this processing widget, we want to be, this is the widget where this is the rectangle on the screen where we actually draw all of the sketch stuff. Whatever our sketch users want to paint, it's painted inside of this widget. Now, one thing that this means right out of the gate is that for the time being, we're not going to honor the control over the size of the sketch. And let me show you what I mean by that. If we come here to the sketch reference, somewhere in here, I think we'll find a size property. Yeah, let's open that up. Defines the dimensions of the display window. For now, we're not going to do it. We're not going to support this concept because the way we're implementing the ability to paint stuff, you don't control the window. The widget is whatever size you make the window. So you control the widget tree around the processing sketch, but the processing sketch itself does not take up the whole window. This is an area where we are fundamentally dealing with a somewhat different environment, and that's okay. But I'm just pointing that out. This sketch or this processing widget will be whatever width and height you make it in your widget tree. Beyond that, how do we allow someone to draw something inside of this widget using a setup function and a draw function? That still remains the crux of our issue or our challenge here. Well, once again, thinking just from a kind of first principles standpoint, somehow we want to support a contract that we will call a sketch, which declares a setup method and a draw method. Somehow this is what we want to support. And then it only makes sense that once we support that, we should be able, the users of this package should be able to pass in a sketch into a processing widget. Again, I say all this without necessarily knowing how we're going to solve this. What I'm discovering here piece by piece is what I would like the solution to be. This is how I would like to be able to use this package. We now have to figure out how to make that possible, how to actually implement it. Assuming that these two methods are implemented by the end user, how does the processing widget actually invoke those methods? Something has to happen here in this build method that results in painting of the screen, right? Well, for now, let's only concern ourselves with painting operations. We're not going to do mouse input, keyboard input. We're not going to animate. We're not going to deal with audio. We're not going to deal with textures. We're just going to deal with fundamental painting concerns. If that's the case, then what we can return here is a custom paint. The size will be infinite, and the painter will be a sketch painter. And again, I'm just riffing here. This is how I kind of stumble through solutions to things is I'm just thinking, what's the next step? What's the next step? We know that a custom painter has access to a canvas, which means one way or another, a custom painter could paint things. Let's define this class called Sketch Painter, which implements custom painter. Actually, I guess we want to extend. Override these methods here. For right now, we will repaint on every frame until we know what the appropriate condition is there. And then we find ourselves in this paint method. How can we allow for these methods here to paint something in the custom painter? Because up here in our widget, our processing widget, we display the painter, but right now the painter isn't painting anything. And even if it were painting something, it has no reference to this sketch object. What do? Well, I have a sense for where we're going to eventually end up, but I'm not going to try to jump there immediately. Let's see if we can get there step by step. The most direct way to implement the functionality that we're trying to achieve here is to remove the abstract here from Sketch. Well, I guess it can be abstract, but we're going to give it some behavior. We are going to, let me back up for a second. To force ourselves to ensure that what we're about to do works, let's pick, let's say, the most basic actual piece of functionality that we might choose to paint, and let's make sure we can get it to work. Let's come back over here to the spec, and let's go to the background command. What background actually does is it fills the available space with a color. I mean, it's described almost like a setting. The background function sets the color used for the background. That explanation is not quite accurate, and let me show you that by way of example. Here's a sketch. We have a setup function and a draw function. Let me uncomment the background color here. This is the color red. Let me run the sketch. There's the color red. That's what we expected. Then to make sure that we understand what happens between setup and draw, in draw, I set the color to blue. Let me run the sketch again. It's initially red and then it's immediately blue. And draw keeps running over and over again, and every time draw runs, it paints the background blue. But here's the question. Does background truly just set a property, or does it take an action? Well, one thing to help us figure that out is, let's uncomment this circle line here. I'm drawing a circle at a random X and Y value with a radius of 10. Let's run that. Notice the circle jumping around. There's only one circle on the screen, which means that every single frame we're drawing the background and we're drawing the circle. So that background line isn't just setting a property, it's painting the background. Because watch what happens if I comment out this background line. Notice that the pixels aren't being erased. Every single frame we're drawing another circle, but we can still see all the previous drawings. What this tells us is that this background line right here is literally painting the background when we call it. It's not just a setting, it's painting the background. That said, we essentially want to be able to implement this draw function right here. Just one line. We would like to be able to define a draw function that calls background with a color, and that color is painted in the available space. If we can make that happen, we're one step closer to a real implementation or a useful implementation of this processing package. Therefore, And again, what I'm doing here is not great for a final solution. It is the first step on our road to implementing these behaviors. One way that subclasses of Sketch can paint something is if we have if we accept a canvas property. And then we can define a background function. Here's another place that, by the way, that we're going to do something different than processing. Processing allows a bunch of different inputs into background, different numbers of parameters, different types of parameters. A single number represents a certain amount of gray. 3 numbers represent RGB, or actually, I think it uses the color mode, so it might be RGB or it might be HSB, but the point is there are 3 color components, or you can pass in an image and you draw an image. For now, we are ignoring image. That's going to be a deeper and more complicated topic for later. But Flutter has great support for color objects, so there's no reason to have overloaded function definitions like this. And who can even remember what these 3 numbers represent? This is an artifact of Java and old style APIs. I don't think this is the ideal way to do things anymore. So we're going to define a background function, but what we're going to do is we're going to take in a color. For now, we will make it required. In the future, we will maybe introduce a second parameter called image, and then you can either pass a color or an image. But for now, we'll just do a color. Inside of background, we're going to do a little debug assertion to say that canvas is not equal to null. Then we are going to create a paint. We're going to set the color equal to the color being passed in. And then we're going to say canvas draw rect. Now, here's one interesting issue is where do we get that rectangle? How do we know the size available to us? For now, we will have that set as well, and we will also assert here that size is not equal to null. We will then say offset 0 and size. This gives us a rectangle starting at 0, 0, which is size width and size height. This line here paints the canvas at the available size with the given color. Theoretically, this should do what we want. So you can call background anywhere within a sketch and you'll get this behavior. Let's connect the pieces here. The only way that canvas and size can be set is if the custom painter sets them, which means the custom painter needs a reference to a sketch. And we'll go with a named parameter here, and that is required. And again, for debugging purposes, we will assert that sketch is not null because that's an inappropriate condition. Then down here in Paint, we can say sketch canvas equals canvas, size equals size. We will invoke setup and we will invoke draw. Let's walk through this. Before we do any painting, the sketch must be given the canvas to paint upon and the size of the available space to be painted. The contract for a sketch says that setup is run first and it's run once, and then draw is run over and over again after that. We currently have no animation going on here, and we won't for the time being. Therefore, draw does not get called over and over again. It just gets called one time. We call setup, then we call draw, and that's it. And that's all we care about. But these two opportunities are opportunities to paint a background. Up here in our processing widget, we have Sketch Painter. We need to pass in our sketch. And now theoretically, everything should work as soon as we actually implement a sketch. Let's prove this to ourselves. We could use the example app, but I'm actually going to go a different route. And I don't know if this is working yet or not. Again, we've put it together, it compiles, it seems like the pieces have come together, but let's go figure out if it works. You could go do this in the example app directly, that's fine. I'm going to show you how to just jump right into tests and figure out in a test if your code that we've written here works. In the Flutter processing package, it looks like we're currently missing a test directory, so I'm going to create a directory called test. At some point, as we get more classes and files, I'll probably put a directory structure in here, but for now, I'm just going to say core test. I'm going to declare a new main method. We will group this for now in a group called core for lack of a better name. And what we want to test is, in this case, user can paint with a processing widget. I'm sorry, this is not a test. This is a test widgets. We're going to do a widget test. But not just a widget test. We're going to do a screenshot test, a golden test. And for that purpose, I'm going to bring in a library. I'm going to add it to the dev dependencies called Golden Toolkit. This is a package put together by the folks over at eBay, and it provides some tools that make it often faster and easier and simpler to write screenshot tests. Everything that you can do with Golden Toolkit, you can do directly using Flutter APIs. You might just end up writing a little bit more code. So let's save that. Let's do a pub get. Let's come back here to core test. Here's what we're going to do. Here's a really neat thing actually about the processing specification. We are shown little bits of code that produces images over here on the left. What this means is that we can go function by function, and we can take the code that's shown here, and we can make sure that it gives us the same image on the left. We can actually build our own test suite based on the examples in the processing specification. Let's begin with background 51. 51, I believe, is from 0 to 255. So this is 51 out of 255, which is about 20% white or 80% black, depending on how you look at it. Let's see if we can paint a background that looks just like this. This square right here, I've found from other examples, I believe is 100 by 100. So we would like to paint a 100 by 100 square with 20% white, or again, 80% black, and make sure that it looks roughly like this image here. In this test, the first thing we're going to do is adjust the size of the quote-unquote screen, or where this screenshot is taking place. And let me see, it's one of these bindings here. Okay, so we grab the window binding from the test system, and we can set the physical size test value. We're going to set that equal to 100 by 100. That's one step we want to take, but we want to take one more step as well, which is the device pixel ratio test value. When it says test value, it means these are the values used in a test rather than in a real app that's running on a real device. We want the pixel density to be 1.0, meaning one logical pixel to one actual pixel. That's what we're used to on the desktop. That is not common for these devices here that have hugely dense screens, pixel dense screens, and logical pixels are usually multiple actual pixels. But on desktop, where we're doing this, we want to go ahead and have a 1-to-1 ratio. This sets up our canvas. We're ready to paint. Next, we need to actually pump a widget tree so that Flutter does some painting. We will say await tester.pump widget. Now, this is the very root of the tree, which means there's not even an app widget or a scaffold or anything. I think technically we shouldn't need one. I guess let's find out. We may or may not need an app widget. The thing about app widgets is that they configure so many things on your behalf. Often you forget all the things they do for you. Let's see what happens if we just directly use a processing widget, which takes, of course, a sketch. So we need to do something for that sketch. That's the widget tree. And then I'm going to come back and implement sketch in a moment. But then we are going to invoke, let's see, I forget the name of this method. Let me go look up the name of this golden toolkit method. Screen matches golden. Screen matches golden. We pass in the tester, and our name for now will simply be core API. Not a great name again, but we're just getting started. We don't know what a good naming convention is going to be for all these tests. We still need a sketch. Let's define my test sketch, which we will say extends sketch. The reason we're extending sketch is because we need those properties. We need the canvas, we need the size, we need the background call. But we still need to implement setup and draw. Now, this immediately shows me one thing that is worth adjusting. We actually should not need to implement either of these. They should be optional. Like for this, in this case, we don't even really care about setup. So we should be able to delete setup. But what happens when I delete setup? Well, then the IDE complains that I'm not fulfilling the contract. Let's go solve that. Let's go back to core. Let's come back in here to our sketch definition. And let's just make these empty implementations. Now, obviously, extending sketch and not implementing these isn't going to do you any good, but it also isn't going to do you any harm. Now we come back to my test sketch, and we can see that it's no longer complaining we don't need setup, and we have draw available to us. Now within draw, again, what's this whole thing trying to validate? We want to be able to set or paint the background the same way you would in sketch or in a processing. So we will call background, which is a local method that we've defined, and we will go with a color. And I said, what, 20% white? So that's going to be roughly that color right there. Now let's see what it's, it needs a named property there. Okay. Now we've defined our sketch. This part here is what we're used to implementing right over here. Now you see the connection between the two APIs. All the rest was infrastructure to allow us to do what we are used to doing. That is this sketch here. We will instantiate my test sketch up here. Again, I have no idea yet if anything we've implemented is what we want. This was all getting to the point where we could find out what's going on. Maybe it blows up at runtime. Maybe it paints something weird. Let's go find out. Here's how we're going to do that. We're going to open the terminal, and we're going to say flutter test update goldens, and we're going to specify this file. Now, and assuming I haven't screwed anything up, it's going to run this test at 100 by 100. It's going to paint the screen, not the real screen, but like a fictional screen, and then it's going to send those pixels to a file. Let's run this. All right, something blew up. Let's see what happened. Okay, so this, because we are using this tool, the Golden Toolkit, it wants us to invoke, instead of test widgets, it wants us to run test goldens, which has the exact same contract. That's a constraint that they've imposed to make it, to differentiate between logical widget tests and screenshot tests, to impose various restrictions. That's fine. Let's see if it works with that change. Okay, test pass. Now to be clear, when they pass in this case, we're not asserting anything. In fact, we're not even comparing goldens. We're just generating a golden. All this means is that no exceptions were thrown at runtime running the code. Let's come over here to test. Here's our goldens directory. Open that up. Open up this image. Well, there's our, and this is zoomed in a bit, I think. There's our 100 by 100 gray rectangle. So the one indicator we have right now is that our approach, in fact, did work. We were able to paint a rectangle. Now, there are a few other tests we can do here, a few other ways that we can poke at this thing. Let's go ahead and do that. Let's come back here and let's call this core draw background, because we're going to add a few more files here. I'm going to delete the core API.png because we're going to regenerate stuff with different names. Let's take this test and let's start making some modifications to it. User can paint background in draw. User can paint background in setup. And from a timing perspective, it makes more sense to run this one first. So first we're going to validate that we can run the background code in setup, and then we're going to validate that we can do it in draw. And then background in draw replaces background in setup. If we're drawing a background in setup and draw, the one in draw should replace the one in setup. If it doesn't, then something is wrong. We now have, actually, let me also add the orange in here, because I actually want to replicate essentially every example from the spec. User can paint orange background. We also need to rename these tests. So core setup background, core draw background orange, core draw background setup draw. Let's say core background setup draw. We now have 4 tests. We have 4 different file names, but we're all using the same sketch. The sketch that we have right now is made for this test here. So paint background in draw sketch. Let's replicate this a few times. First, let's do the setup, paint background in setup. And let's just rename this to setup, and then everything else remains the same. Then we'll come down here and we'll say paint orange background sketch. For this one, we actually need the orange color, right? So that's 100% red, 80% green, no blue. Therefore, 100% red, and I don't know, what's 80% of 16? Something like CC? I don't know. Something like that. That's right there is close enough. And finally, the paint background in setup and draw sketch. This one's going to do it twice. I'll just make the initial color red, and then let's bring the gray back. Now we have 4 different sketches for 4 different tests. Let's actually use them. Paint background in setup and draw sketch. Paint orange background sketch. paint background in setup sketch. 4 tests, 4 sketches, 4 files. Let's generate all of them and see what happens. All tests pass. Let's look at our goldens. Here's the original one, still doing what we thought it would. The one that does it both, so the one that runs in setup and draw, also is gray, which is what we expected. It started with red, it ended with gray, or I think that's what we did, right? Let's see. Yeah, started with red, ended with gray. Started with red, ended with gray. Painting orange, here's our orange one. And here's the gray that's painted in setup. So every one of those combinations, every one of those different times for us to paint the background, it did exactly what we thought it would do, which means as far as we can tell, our implementation up to this point is good. And now notice, we were able to validate everything that we did without involving the example app. Now, I'm not saying you should avoid the example app. I'm just pointing out a way that you can develop APIs and implement APIs, or design and implement APIs, by using tests as a feedback loop to figure out, okay, I just did something. Does it do what I thought it did? Writing widget tests, screenshot tests, logical Dart tests or Dart language tests, whatever. Those are all tools at your disposal. We now have the one piece of functionality that I wanted us to prove out. Here's something that I don't like. Look at all these classes that we just had to implement here. Fundamentally, I don't think this should be necessary. I think we should be able to implement setup and draw functions right here. Now, I don't know exactly how we can do it yet, because there is a complication that your setup and draw functions need access to all of the painting APIs. It's unclear how to provide that, but I'm sure we can do better than this. That's something to work on in the future. Clearly, what we have here is not perfect, but what we do have right now is a processing widget that you can place anywhere in a widget tree. It will run a custom painter. That custom painter will allow a given sketch to do whatever it wants in setup and draw using a canvas at a given size. And the one thing that we've implemented here is background. So like right here, we can say to do, implement all other processing APIs. And we can come up here and we can say to do, implement animation frames, keyboard input, mouse input. These are things that we still want to accomplish. And up here, taking in a sketch is probably fine, but we can put the to do right here. To do, find a way to allow for sketch implementations to avoid subclassing sketch. These are all things, all work work issues that we need to handle or resolve, etc. But this is the starting point. What I'm going to do now is I'm going to commit this. I'm going to put up a pull request. I'm going to merge it into the main branch. And in the next video, we're going to come back and we're going to dig into first this issue of how do we avoid subclassing all the time? That's a fundamental API problem. I do not want end users of this package to have to subclass all the time. It's a big pain. How do we avoid that? We're going to solve that in the next video somehow. And then after that, we're going to really start picking out one API after the other. We're going to implement it. We're going to write screenshot tests for it. And then eventually we're going to start integrating some of this into the example app. So I'll see you then.